And again, I know the number one thing you all want to see is me. Here I am. So, we discussed this before, and I was told during our conversation that 4 people all told me the same idea, and I had misheard them all, and that could very well be the case. But I am going to just dig in on this point because I actually heard certain keywords from the various 4 descriptions I heard when I asked people how to do arbitrary triangles that made me think that we weren't saying the same thing. So, first off, this first bullet is important. What we described in the pseudocode for the scanline algorithm, that applies to arbitrary triangles. It doesn't really need to be that it's a going up triangle or a going down triangle. The reason that you care whether it's going up or going down is because it makes some of these intersection calculations easier. Okay? And but the way that I recommend you all deal with arbitrary triangles, and in 1C they're except for one, they'll all be arbitrary triangles. Maybe it's more than that. I don't know. I put some statistics up. Is to split it in half. And so the reason that I kept saying what I was hearing sounded wrong to me is I kept hearing the phrase bounding box, and I felt that people were describing it, they wanted to sweep lines on the top half, and then when they're in that side of the bounding box, and then in the bottom half. And I don't care whether I heard wrong or not. What I want to say is, this is what I'm recommending you do for 1C. You have a function called rasterized going down triangle, or something. Actually, look, having graded all the 1Bs that were submitted last night, many of you don't have functions. Many of you just do it in your main loop, okay? I would recommend you take what's in your main loop and you put it into a function called rasterized going down triangle. And you can make another function called rasterized going up triangle, which is just a matter of just kind of changing some logic about minimum y's and maximum y's. If you want to be clever and have one function and a Boolean that gets passed in or not or whatever, you're welcome to do that. But my recommendation is that you make a function called rasterized arbitrary triangle. And the first thing it does is it splits it into 2 triangles. So you walk the triangle, you figure out where the middle y is. When I say middle y, I mean this y right here. Of course, it's easy to look at pictures and immediately infer what it is from a picture. But that you find the middle y, and then you generate, there's a triangle struct, generate a triangle struct that has these 3, here's middle y that has these 3 points, including you have to calculate the x location of that vertex. And to generate a triangle struct with those 3 vertices, and generate a second triangle struct with these 3 vertices, and then just call your existing functions, okay? So my proposed plan of attack is you do the split, and you make 2 triangles, and then once you've done that split with your 2 triangles, you just call your 2 functions, okay? That's what I was advocating for 1C. Perhaps that's exactly what people were telling me. In some cases, people were describing bounding boxes, and I think they were just describing to do sweeps of one and then sweeps of another. Doesn't matter. That's my proposed solution for you. It's due next Wednesday, so 8 days from today. Goal, apply the scanline algorithm to arbitrary triangles. We already talked about this puddles thing. It's different now. In 1B, there was in the starter code a routine to generate the geometry. Now you have to download an 80 megabyte file. And if you look at my code, I have a new routine called get triangles, which opens that file, right? proj1c geometry.btk. And if it can't open it, then it will issue a print statement. If you see this print statement, unable to open file, don't post to Piazza saying you're confused. The issue is you haven't downloaded the file and put it in the right place. Put the file in the right place, okay? And so, but this is the new get triangles routine, and your 1B, there was a function with the exact same signature, get triangles. For 1C, I just recommend you just copy project1b.cxx to be project1c.cxx to go into this get triangles that you got from my 1B starter code and to remove it, and to go to your 1C right here, just copy this and paste it and put it in. That's what I recommend. I also did not post a cmakelist.txt file because I think you all have winning ones now. You should just copy your cmakelist.txt and change it from proj1b to be proj1c. Okay. I don't think it's that hot, and I think the noise is distracting. Okay, so this is going to be hard. Conceptually, it's not much harder than 1B. What makes it hard is now you've got a million triangles, and you're gonna. Here's a possible scenario: you implement it, you run differencer, and it says, "Oh, you've got 500 pixels different." And they say, "How do I debug that there's 500 pixels different?" Right? So there are some breadcrumbs here. That's not big enough to see, is it? Okay. These two outputs come from a file I've posted on the class website. So if you go here, it says, here's a data file that contains, oh, here's a file, the last one, here's a file that contains the triangle IDs deposited into each pixel. So the very first line of this file says format column row equals triangle ID. I'm going to ignore the second line. And then here, this would say in column 929 and row 614, the correct answer that you're supposed to match, triangle 211,528 deposited to that pixel. Okay? So if you run differencer and it says, oh, I have a difference with you with a given pixel, then this is a starting point. You can say, oh, well, let me go and look at this triangle and see if it deposits its color into that pixel. And you can start working out the math behind that. Another thing that can happen is that you deposit a color into a pixel. And then so in this case, it's supposed to be triangle 211,528 into a pixel. And you do that correctly, but then maybe another triangle comes and deposits its color into the same pixel over the top of the first one. In that case, this file wouldn't help you, but you would still know the pixel that is different, and you could add some print statements there surrounding around the setting of that pixel. So in my code, I have a setPixel method. And my guess is that many of you, after watching the discussion that follows next, will decide to add a setPixel method. It's super handy. And so, how did I get, these outputs here from my program, where it says triangle 211,528 is writing to this pixel. I did it by just instrumenting my program. So I put a print statement into my setPixel method. And then I needed to get the triangle ID, and I set that as a global variable. Whoops. And then I just set the global variable in my for loop. Okay, so it's not very hard to set up your own code so you can get this information as well. Okay, so I said I think several of you are going to add this setPixel method. I don't think you'll do it based on the pitch that you've heard so far. But I actually want to spend some time talking about what went wrong in some of your 1B submissions, and it might inspire some of you to do a setPixel method. So before I go on, because I actually took some screen grabs from what I saw on Piazza, and I want to talk about that, and I won't stop the video. I'll keep the video rolling to talk about that. Are there any questions about 1C, just the prompt or anything else before I push forward? Yeah, Ethan?
What is the proper behavior for multiple triangles overlapping the same pixel?
Yeah, so that's a great question. What is the correct behavior when you have two triangles overlapping the same pixel? Answer, in 1C it doesn't happen. And so if it does happen, it's actually because you have an error in your code. So it's a great question. In the lecture that follows in 1D, we're going to change the rules and say it can happen, but we'll be very specific about what to do. And but in 1C, it shouldn't happen. If it does happen, it's because there's a problem with your code. Anything else about 1C? Okay. So this was a prompt or a post on Piazza, and it said basically it was providing evidence that there are negative y values in the triangles. I know this, right? I did it on purpose. If we go and we look at project 1B with the beginning program, oops, that's 1A. I made that mistake last time too. And 1B, see right here, I'm saying like if I is 50, do something wonky. If I is 5, set the y value to minus 50. I know it. I'm doing it on purpose, right? If you look at the right answer, that right there is triangle 5, and one of its vertices was pulled way down, okay? So you know, negative y values, you know, I think this post was saying, hey, you've got some bad data. That is not what I'd like you to conclude. What I'd like you to conclude is your routines need to deal with this case, okay? And I put it in to make you deal with it. Now, we had a separate piece, which is many of you wrote code that worked on your machines that didn't work on my machines. We'll talk about that in a second. I have to say there was one submission I looked at that I was actually unhappy with. I still gave it full credit because it produced the right picture for me, but in the rasterization routines, it said, if I is 50, then do this special case. If I'm rasterizing triangle 50, do this special thing. Or if I'm rasterizing triangle 5, do this special thing. That is not my intent at all. I would like you to build routines that work with any triangle. So it should not be the case that you're looking at my triangle generation routines, decide that these two that I made wonky are problematic, and undo the wonkiness I did. The wonkiness is there because I want you to practice dealing with it. Okay? Now that said, I said, you know, if you produce the right image, you can get full credit. So I gave it full credit, but I also gave that person feedback of like, hey, this is not what I intend. So in terms of this post, negative y values, yes, agree. Okay. In terms of this post, and I actually, of the submissions I got, I would say 25% of them crashed for me. That's a pretty high rate. And so you know, we said that we didn't need to have a reference machine. I wanted to spare everyone the hardship of going to another machine and running there and confirming it runs there before you submit to me. If it continues to be that projects fail at 25%, then we'll have to figure something out. But for now, let's just keep the way we are. This is, and for the 25% that it failed, I would send you something like this. First off, I would run it in a debugger. Many of you continue to be scared of debuggers. Please don't be. Debuggers are your friend. They are very helpful, right? And so I think, I don't know, who's taken 415? Good. And you can't get through 415 without actually figuring out debuggers, right? Is that fair? I'm saying no's. Okay. So I'd say debuggers are great, and they're great for this sort of issue. And so if we look at this right here, is this big enough? It's not big enough. Let's make it bigger. Is that big enough? I don't know. We're getting there. So in this case, someone was writing to a buffer, and on my machine it crashed. And so again, I ran it within LLDB. It said this was the line of code it crashed on. And then I said, what's the index value? And the index value is negative 91,488. By the way, debuggers only run well if you compile with debug information. Here is the magic line to make CMake compile with debug information, okay? And so it's actually, you know, and so then there was a follow-up post, which is, why would this not crash for the person who turned it in and will crash for me? Well, so first off, I hope we all agree that writing to buffer of negative 91,000 is bad, right? And it's not always bad. I mean, well, no, let me say, I think it's almost always bad, unless you're doing something really fancy with pointer arithmetic where you've taken buffer and advanced it 100,000 bytes, and you want to, but everything before it's still valid, which is almost certainly not the case. It's bad to write to negative values of an array. There's some big layout of memory from left to right, and buffers at some address, and when we write to negative 91,000, it's just going back here and writing over someone else's memory. So why did it run for someone else? Maybe they wrote to some memory they never accessed again, and that was okay. Why did it crash for me? Maybe on my Mac, which, by the way, if you use Mac and you think when you say GCC, you're getting GCC, you're wrong, you're getting Clang. So I'm using maybe a different compiler, which is Clang, and the layout is different. The way that they put stuff at the beginning with the C standard libraries is different. And for me, negative 91,000 is not a valid memory location, and so it crashes, right? So it comes down to when you're doing memory operations and you go outside of your buffer, what happens next is just not known, right? It just depends on a lot of other factors in terms of how the memory is laid out, and it's not consistent across machines or compilers. And so in my case, this was a crash. And frankly, I would think any of you would look at this and say, oh, that's not good. I shouldn't do that, right? If you say I'm running the buffer of negative 91,000, that's not good. So I want to do a little bit of thinking about how did we get buffer of negative 91,000. So let's bring up a terminal. And I guess, so we'll make a screen that is P0, P1, P2, P3, P4. Sorry. Okay, so now we've got a screen that has a width of 5 and a height of 3. And we've got our formula, which is if we've got some pixel at a given row and column, or maybe we want to denote it as column row. Of course, you'll see conventions vary, right? When I say it, I like to say row column, but actually when I think about it, I'd really prefer to have it be column row, because column is like the X and row is like the Y, right? So these things flip on the convention. Just be aware, right? There's really, either convention is fine. So the index would be the row times the width plus the column, okay? And then since we've got 3 unsigned characters, if we've got a buffer, we'd actually want to go 3 times the index plus 0 for red, 3 times the index plus 1 for green, and plus 2 for blue. And so this would be row column dot red, green, and blue. Is that big enough? Should I make that bigger? People in the front all nod, it's big enough. People in the back, is that big enough? Okay, good, thank you. So, first off, what's one thing that can go wrong? If the row is minus 1,000 and the column is 2, then our index is going to be minus 1,000 times 5 plus 2, which is, looks like minus 4,998. That's not good, right? So how is it that you're getting negative indices? It's because you're considering rows that are negative, right? And so if I give you a triangle, and as far as I'm concerned, this is a perfectly valid triangle, then when you run your scanline algorithm, you're going to say that the ceiling of the floor, the ceiling of the minimum y is minus 1,003, and the ceiling of the max y, sorry, the floor of the max y is 1,000. And then you're going to have some for loop over these y's, right, for and disaster ensues, okay? So it's important, it's fine to be processing scan lines that are outside your image. I'd actually encourage you to do that. What's not fine is to take the resulting indices and deposit colors at those indices. And so for many of you, you're getting negative numbers, or you were getting numbers that were too big, that were past the end of the buffer. So if you looked at the example in 1b, the way this math works out, all the last 10 triangles end up at a y value of 1,000, which is along a scan line that we're not allowed to touch. And so for many of you, I got problems because you were actually trying to write to this row of pixels that was just beyond the top of the image. Okay? So you need to be checking for this and disallowing this case. And I said before, I find the easiest thing to do is to have this right here and just check right here, right? That's what I find the easiest to do. Now, I saw for many of you a lurking problem. For many of you, you had some stuff in here saying, oh, it's a negative value. You'd say if, so let's call this like top scan line, and this one we'll call bottom scan line. And you'd say, well, if the bottom scan line is less than 0, then set it to 0. And there'd be some other variants actually left end, right end as well. If I'm past the end, set it at the end. This is not good. This will lead to trouble. Let me show you how this will lead to trouble. I thought about this morning and decided I was just going to do this by PowerPoint. And I've seen this repeatedly in people's 1C projects. So here's going to be our screen, and here's going to be a triangle. That's not what I want. And both of their scan lines are below the bottom. I often see logic where people will set the scan line and say, oh, that's less than 0, set it to 0. That's less than 0, set it to 0. And then for this triangle, they'll set a scan line and actually deposit colors to the bottom image here because they'll decide that scan line 0 is legit. And if you take this triangle, this edge would interpolate up to that point right there. This line would interpolate to that point up there, and they'll deposit colors all the way along there. They will be not interpolating, but extrapolating. They'll be going beyond the boundary of the triangle. And then they'll say, oh, my image is just right, but at the edges I have all this croft. And it's because they've got triangles that are fully outside the screen, but their logic is one where they're trying to set things to be at 0 or the max or whatever. Okay, you guys seem bored to death. This is not interesting? I feel like this is saving you hours of your lives, but yeah, other people don't think that. David, what do you got?
Can you go back to your code that you were just displaying?
Sure.
Now, what is this, like, you get this function name, string, : set pixel?
Yeah.
Should you just call it set pixel? Like, what does that give you? Like,
I mean, so to me, you could just have a set pixel. In 1B in my skeleton code, there is a screen class, and then it says, like, would some methods for accessing and setting pixels be helpful? So you don't have to pass around the buffer. You don't have to pass around the width or height. It's just a method associated with that object.
Cool.
Okay. I'm going to stop the video unless there's other comments or questions.